In this video, we're going to look at an example of integration by recognition. And you'll see the process unfold within this example. But the basic idea of integration by recognition is we use a known derivative or a derivative statement to help find an integral or an antiderivative that we wouldn't otherwise be able to find. So let's have a look at the example, and it says for part A that we want to differentiate xe to the power of 3x with respect to x. And then for part B, we want to evaluate the integral between 0 and 1 of x times e to the power of 3x dx. So first of all, if we're asked to differentiate xe to the power of 3x, that's two functions multiplied together. So we know that we're going to need to apply the product rule. So to apply the product rule, you could go through and let u equal the first function x, and v would be the second function e to the power of 3x. And then we need to calculate du dx, and the derivative of u with respect to x is just 1. And we would also calculate dv dx, and the derivative of e to the power of 3x with respect to x is 3e to the power of 3x. And now to apply the product rule, we do u times dv dx and v times du dx, and it sort of forms a multiplication symbol up there, as you can see. So to complete that over here, I'm going to write that the derivative d dx of xe to the power of 3x is simply equal to x times 3e to the power of 3x, which I can write as 3xe to the power of 3x. And then we add on to that v times du dx, which is e to the power of 3x times 1. So that's simply e to the power of 3x. So part B now asks us to hence evaluate the integral between 0 and 1 of x times e to the power of 3x dx. And ordinarily, using the rules that we know for integration, we wouldn't be able to find an antiderivative for something like xe to the power of 3x. However, this hence indicates that we must be able to use the answer above somehow to help answer this question. So we're actually going to start this question off with a statement. And the statement relates to the derivative that we just found above. So I'm just going to rewrite that out to start with. So that is that the derivative d dx of xe to the power of 3x is equal to 3xe to the power of 3x. And then we still add plus e to the power of 3x. And the reason why that's useful is that we can actually integrate both sides of this. So we could have the integral of the left-hand side with respect to x be equal to the integral of the right-hand side with respect to x. And that's the integral of all of those terms, of course. So the reason why that's useful is we've now got the integral of an xe to the power of 3x term appearing in our working. So moving on to the next line, if I just put that here, the integral and the derivative here undo each other, they're inverse operations. So on the left-hand side, we're just going to be left with xe to the power of 3x. So I'll go ahead and write that down, xe to the power of 3x. And that's going to equal, and on the right-hand side, if we have the integral of 3xe to the power of 3x, we can then split that away from the plus e to the power of 3x, because we can do that with integrals. That's one of the properties we have. So the 3 could also come out the front because it's a constant. So that could be 3 times the integral of xe to the power of 3x dx. And then we can add on to that. And we have the integral of e to the power of 3x dx was the second term over here that we had to deal with. And what we can do is we can now integrate that. That's something we can do. So when we integrate that, we have 1 on 3. We divide or multiply by the reciprocal of the coefficient of x. So we're going to have a third e to the power of 3x. And technically we'd have a plus c here because we've now performed integration and we get that constant of integration appearing. But because we're about to calculate a definite integral, that won't really matter. But we can leave it there for the time being as good practice so we don't forget it. So the part of this that we're really interested in is this integral here, the integral of x e to the power of 3x dx. So we want to get that by itself, and to do that we've got two things we're going to subtract away from it, and we also need to divide by that 3. So we're going to do all of that in one step, so hopefully you can follow along with me. And I'm just going to write the thing that we're isolating first. So the integral of x e to the power of 3x dx is going to equal. And for this term, we were going to divide it by 3, so we can write that as 1/3 x e to the power of 3x. And then we were going to subtract away this term, so we're going to have subtract away. But once we subtract away 1/3 e to the power of 3x and we divide it by 3, that turns into 1/9 times e to the power of 3x. And then technically we'd subtract away the c and divide it by 3. And that's what it would look like if we were asked to find the indefinite integral. However, we wanted to find a definite integral. That's the one with terminals. So I can go ahead and put a 0 and a 1 on there. And that means we just have to change the right-hand side slightly. So we put a square bracket around our antiderivative, and we can cut that off here. But because when we do a definite integral, we don't have to worry about that constant, I can go ahead and get rid of that. So now when I close off this bracket and evaluate it between 0 and 1, that's the antiderivative that we're dealing with. So now this, when we work out what this is equal to, we would have the upper value of 1 substituted into the antiderivative, and make sure you use brackets here. So when I put 1 in here, I'm going to have 1/3 times 1 times e to the power of 3 times 1, which is just 1/3 e to the power of 3. And then when I put 1 in that second term, we'd have minus 1/9 times e to the power of 3. And then we'd subtract away from that the antiderivative with 0 substituted in. So substituting 0 into this first term, we get 1/3 times 0 times e to the power of 0. And because we have a 0 wedged in here, anything that's multiplied by 0 is still going to be 0. So we can just put 0 there. And then we'd have minus 1/9. And then we would have e to the power of 3 times 0, which is e to the power of 0. And e to the power of 0 is simply 1. So we could put a little multiplied by 1 there if you wanted to keep track of what had happened. And now we're really, really close to an answer now. So we could say that this is equal to, and in this first bracket, we've actually got like terms of e to the power of 3. So we might want to get a common denominator here. So I'm going to pick a common denominator of 9. And if I want a common denominator of 9, I don't have to do anything to the second term, so that's just going to be minus e to the power of 3. But for the first term, I'd have to turn that into 3e to the power of 3 on the top line. So that is now with a common denominator. Over here we have subtract negative 1/9, which just turns into plus 1/9. So the last step that we can do here is we could just simplify that first fraction. So 3e to the power of 3 minus e to the power of 3 is going to give 2e to the power of 3. And we could put the plus 1 alongside that, and all of that is divided by 9. So this is the answer to part B of this question. So I hope that helps, and stay tuned for more videos on integration by recognition, as well as other videos on maths.